Hi, Kevin. Hi, hello everyone. Can you hear me?
Yes.
Okay.
Good morning.
Yes, really.
Good morning, everyone. Okay, so I think let's start. Thanks for dialing in today. I know it's Saturday morning. of where you are. So we will have the discussions about the paper show at 10 and 12 today. The facilitator will, sorry, there's a noise. Okay. Uh, okay, so we will, as announced earlier, that we will have the very first 10 minutes for a quick introduction. Maybe everyone can give, like, you can either turn on your mic and give a quick 30 seconds introduction or drop a note about yourself on the chat message. Okay, I think let me start first. Um, So I'm Daphne, community manager of Hasbrain. Hasbrain is a social enterprise. We run these activities to help everyone create an environment for everyone to come together, learn, and access to proper opportunities. We run these activities on a bi-weekly basis. So for the next 2 weeks, we will have another meetup. I will post on our social media channels. The link is okay, if you can see the screen that I share, then those are the link. Feel free to join in the Slack or Facebook group or like our Facebook fan page to receive notifications about other activities. So we run all the activities for the communities, and you can expect to join in for free, networking with other members in the community. Okay, so that is a brief about myself. Maybe the next person, Kai, do you want to introduce yourself?
Sure. I can drop a two-line. So I founded the organization together with Flownote, and the primary focus is basically trying to bring people together to learn better. And this stems from one of my own pain points when I'm learning. I think having a community basically acts as a forcing function to basically share more knowledge. And in general, I think it is difficult to kind of wake up every Saturday to do this, but I think it's highly beneficial. So for myself, I'm interested in NLP topics. I'm interested in changing in general, like I think image segmentation. So I'm currently building some pet projects right now and also applying NLP to our core product Flownote. Yeah, cool. Nice to meet you guys.
Cool. Okay. I think maybe the next one, Peter and your turn.
Maybe I'm gonna go next.
Yes.
Okay, hi everyone. Uh, okay, let me turn on this. Hi everyone. My name is Quốc An, and I'm the one who was suggesting the discussion about this paper for today. I'm a graduate from University of Science and currently working as a research assistant at my university, University of Science. And I hope we can have a good discussion today about this topic. That maybe that's all.
Okay. Cool. Maybe Anne, you can point a person's and any names in the chat list.
Any name?
Yeah.
All right. So how about Kevin?
Kevin.
Hello.
Hi, Kevin.
Hello, everyone. My name is Kevin, and currently I don't have work, but my past job was at Nokia, software engineer for their 3G software. And currently I'm interested in machine learning, so and the topic for this day got me interested. So yeah, that's all about me.
Sure. Cool. Where are you from, Kevin?
Hello. Can you repeat?
Where are you from?
I'm from Philippines.
Sure. Okay, cool. I think we are everywhere on the world. Singapore, Vietnam, India, and Philippines. Okay, welcome Kevin to the community. Kevin, can you point a person to be the next one? Let's pick a name.
Leonardo.
Leonardo. Okay. Hi, Leo. Can you hear us? Oh, Leo. We cannot hear you, Leo.
Leo?
Okay, maybe there's a technical issue with Leo. Oh, 1 second. Okay, sure. I think maybe while waiting for Leo, Vin, do you wanna give intro about yourself? Leo, maybe you can drop a note about yourself. Okay, sure. Vin, are you there?
It's quite noisy here, so I think it's not my time today. But anyway, my name is Vinh.
Okay.
Currently, data scientist and lecturer. Yeah.
Okay, sure. Okay. Vin, can you choose the next one? I guess there are only Mosens and Vihan. Oh, and Kiernan. So how about Yuhan?
Okay. Can you hear me?
Yes.
Oh, yes. Loud and clear.
Okay. So my name is Yuhan, and I'm a junior in UC Berkeley studying data science. And I'm actually volunteering in Hespering, and it's my first time joining the session. Hope everything goes well. Hope you guys enjoy.
Okay, thanks, Yuhan.
Yeah, no problem.
I guess it's.
Do you want me to point?
Oh, yeah, Yuhan, let's point the next one.
Who do you have left?
Mosens and Kiernan's, Leonardo,
And June Fox, the new guy.
True Fact, Patrick.
Okay. I'll pick Mosen.
Okay.
Hello, I'm Mohsen. I'm from Iran and I'm interested in data science. I want to learn machine learning and hopefully use this information in marketing in future.
Okay. Mosen, can you pick the next one? I guess there are Patrick left. And I'm not sure if I pronounce your name correctly. Kiernan, is that correct? Okay. Hi, Patrick. Patrick?
Can you hear me?
Yes.
Oh, right.
Can you introduce yourself?
Hi guys, my name is Fat. You can call me Patrick. I'm currently studying in computer science, and I really enjoy studying about deep learning and computer vision. Nice to meet you guys.
Great. Okay, then I guess Leonardo, maybe you can do an intro now.
Hi, can you hear me?
Yes.
Okay. Hi everyone. I'm Leonardo I'm working in Brazil. I am working in AI startup doing projects about face recognition, post estimation, this kind of things. And I'm very interested in this kind of applications. I was reading this paper when I was on undergraduate, so I liked a lot of this topic. So I am very happy to be with you. Thanks.
Hey, thanks for coming down today. We have one person left, Kianan, but I'm not sure if I pronounced that correctly. Correct me if I'm wrong. So, do you like to do an introduction by yourself?
I, okay. Hey, actually that's my company's name, so I use my company ID.
Sure. What's your name? How can we call you?
Yeah, so my name is Ling.
Ling.
Mm-hmm. Yes, I'm actually admin of the Facebook group Data AI at Saigon. Yes.
Oh, Data AI. Oh, you're.
Okay. Yeah, it's me.
Okay.
Okay. So a quick introduction about myself. I'm now how to say it, a lecturer at the University of Industrial University in Ho Chi Minh City. I think that's the correct name of the university. Yeah.
Okay. Hi, welcome Lynn to the community. Okay, I think we should start to the discussion now. To set some initial expectations for you guys when coming in to the discussion. So please take it as an informal meetup that we come together and talk, exchange thoughts about papers. So I hope that there should be two-way interaction between not only the facilitator but also from the community. Feel free to, if you're shy to speak up, then just raise your question in the message. It should be fairly straightforward. Or you can, there's some feature from Zoom that you can use to say whether you agree or disagree, whether you want the speaker to go slower or go faster. Okay, so I think let's dive into the discussions with the facilitators is Anne. So Anne will share screen and give some thoughts about the paper, and then everyone can. Do you guys think you would like to raise questions immediately or wait until the very end? What should work better?
I think it should be depend if the question is so urgent and they feeling the need to understand it immediately. I think that it's free to raise a question.
Okay, so if the question affects the understanding of the whole presentation, then maybe they can just raise it immediately, right? Okay. Okay, sure. Yeah, I think then anything else? Okay, I think that's it. Let's welcome Anne. Anne, it's your stage now.
All right. Please turn off the sharing screen from your.
Okay, sure. Okay.
All right. Are you seeing my screen now?
Yeah.
All right. So this is the paper I selected for today's discussion. Show attend and tell neural image captioning generation with visual attention. I prepare a little bit a short slide for briefly go through the paper if you haven't read it yet. So the paper is about the topic about image captioning generation. So let's look a bit about the problem, image captioning. What is image captioning? The image captioning problem is aim to generate a sentence that can describe the content of an arbitrary input image. For example, like this one, you are given an image to the computer, and the computer duty is to generate a sentence that describes the content of the image. Like given this picture, it have to say the woman is standing next to a horse. So actually, the ground truth for this kind of problem is quite loose because you can describe anything. You can describe a man, you can describe about a woman, and a lot of things can be described in an image. And how to describe it and how to form the sentence in the correct grammar and other thing is also a hard problem. That's why the image captioning problem is quite challenging and is catching some attention from researchers. This problem has been around for a while. Some early methods use they use detection method. They detect what objects are there in the image and then use the word they detected to fill into some template sentence. And since the development of deep learning, recent papers, recent research work now use deep neural network for directly generate the sentence from a given image. So the method in this paper, they use the sequence-to-sequence framework. That means from an image, it will be processed through a multi-layer neural network and to give out a final sentence by generate one word at a time. Like given the input, they're gonna generate the word and then the word bird, and then the word flying, and keep going on until the last word is generated. And the special about this paper is it's kind of the first one to use the visual attention mechanism on image. The visual attention mechanism was introduced firstly in natural language processing, and this paper adapt the method into the image and use it in image captioning problem. This paper is not one of the latest, but I choose it because it's one of the breakthrough when the visual attention mechanism is applied successfully in image and can prove more understanding and more useful method for processing image. Any question?
No, it's pretty good.
All right. So let's move on to the detail of the model. So firstly is the first part of the model is the feature extractor. You can see here, the feature extractor. They are given an image. You're gonna put it through a feature extractor via a convolution neural network. So given a convolution neural network, especially in this paper, is the VGG architecture, it's gonna process through and give our feature map. And a little bit note that we're gonna drop the final fully connected. We only use the convolutional because before going into the fully connected, the information are still organized in the spatial. You mean like this corner gonna correspond to this corner, right? So they're gonna still have the order in the spatial space, in the space, 2D space. So and the next one is gonna go through an attention mechanism before generated word by word. So how does the attention mechanism work? There are two kinds of attention mechanism, the soft attention and the hard attention. Think about attention like how you pay attention to something. Like when you look at something, you have a whole picture, right? But you only focus on a little part of the picture. So the attention mechanism is actually implemented via a small network. So the small network gonna compute via softmax to calculate the score, or you can call it the weight. And each region in the image gonna be assigned with a weight, so that the region with a high weight gonna get the attend into that. That means when you multiply the weight with the value in the region, so if the weight is high, the value gonna be equal to 1. If the value is equal to 1, it here. Okay, if the value is kind of equal to 1, then the region gonna be kept. But if the weight is equal to 0, the region gonna be eliminated.
I think Leo had questions. Why they didn't get a feature vector using ResNet?
Oh, maybe because this paper is quite before the ResNet is popular. This paper is from 2015. So currently they use the current version of VGG, but recent paper begin to replace the VGG with ResNet already. So I choose this paper not because it's one of the state of the art, but I think we kind of go from the beginning, a breakthrough, a breaking point where attention mechanism and sequence-to-sequence model apply into image captioning and prove a lot of improvement in image captioning problem and more understanding in image processing. I hope that answers your question. So the soft attention, like that, you can imagine attention is in that way. You're gonna use a way to assign for each reason. And the special thing about soft attention is that it's the differentiable. That means you can differentiate to calculate gradient descent and change along with the whole model. And why is it called soft attention? Because it's softly selected. That means the weight is not exactly equal to 1. It could be like 0.9, 0.8, and something like that. And when we're going to sum up the weighted region in there. And about hard attention is quite different from the soft attention, that the weight it must be exactly equal to 1 or 0. That means you will choose or not choose, or not in the blur, the fuzzy region, the furry area. You have to choose or not. So it's not differentiable because like the side function, this is 1 or 0. It's not a smooth line, so there is no differentiate there. So we have to change it by a reinforcement method or approximate gradient. Like you create a approximate differentiation, and it hardly selection the region in the feature map. So you can look in at some example below. This is an example of hard attention when you can select the correct region. Yeah. So only one region is selected, and the other are eliminated. And this is the soft attention. That means you don't really have to eliminate. The region can be blurred in some place. Some place is gonna be darker, and some place can be brighter, like that. So how can we generate the work from that? From the given region we are paying attention to, the network gonna go through an LSTM model to generate a sentence, a word at a time. So the attention gonna give a new region, what are we looking at? And the LSTM will create a word, what word is corresponding to that region. And then the hidden state are gonna be given back to shift the attention to another region. And the region gonna give another corresponding word, and the process keep going on until the last word of the sentence, or the special character, the end of sentence character, to terminate the process. So sum up, you can see the whole process in here. From a given image, you want to process through a convolution neural network, and then through attention by looking at different regions at a time, and generate a corresponding work according to that region. And the whole process is trainable by a soft attention. Also approximate gradient if you're using hard attention, and therefore there is no human knowledge in here. The attention gonna learn how to shift the attention based on the data. And this gonna give a really breakthrough because we can see the final reason that the computer can pay attention to specific and corresponding object. Like when he want to generate a little girl, he gonna pay attention on the little girl. But when they want to generate a teddy bear, you're gonna pay attention on the teddy bear. So there will be less noise from the other object that can affect the current object you are want to pay attention to and generate a word. I have a video to show the example. You can see the video like this. Like that. We're gonna pay attention into different reasons at each time it generates a word. For example, when it generates a woman, you're gonna pay attention to the woman. And when it generates snow, and when it generates ski, you're gonna pay attention to the ski. and something like that. So I think one of the questions we could discuss about today is, what do you think about this mechanism, the attention mechanism? And what do you think can improve the image captioning problem? And what challenges is ahead of us for this image captioning problem, as well as what we can apply into the real world if we can solve the image captioning problem?
I have a question. Can I drop it now?
Yes. Yes.
So I think from the video it looks okay. So I think what I'm trying to understand here is that because the neural net looks like it's processing this in parallel, right? So how does it actually decide that let's say there is some form of like a saliency map, which is like a attention, right? How does it decide that like the first word is going to be a zebra?
Yes.
Right? Like how does it decide that? Like because everything is in parallel. So why not just start with grass?
So yes, actually it's only data driven. The deep learning method is always depend on the data. So in the raw truth, like the MS Coco dataset, in the MS Coco dataset, we an image gonna be given 5 different captions, and we train the model on that. So if this image in the training dataset, they focus on the zebra, then the model will more likely to focus on the zebra for a similar image. So first, when you given an image, the model gonna have to learn where it should attend first from the whole view of the image. So within the first word, within the first image, it's gonna shift the attention into somewhere that more likely that should be depend on the data. Like for this kind of image, it's gonna pay attention on this area first, but for different image, another image, it's gonna have to pay attention to another place like that. And from this one, it's gonna generate what is the corresponding word. And from that, it's gonna shift the attention to the second word. And from that reason, we generate the second word. And the process keep going on. So kind of not really parallel, but it's recurrent. Like when it generates a word, then the information from the word gonna feedback to shift what gonna need to be looked at next. And from that, the new reason we generate a new word. And from the new word, we're gonna go back and look at a new reason. And from the new reason, we keep going on with the new word, and the process keep going on like a loop.
Okay, so is my understanding correct that the soft attention basically scans the pixel by pixel from the top left all the way to the bottom right, and then it picks out like all these regions?
Actually, not really the pixel by pixel. The attention is applied on the feature map of the convolution neural network. That's why we don't use the fully connected. The fully connected no longer hold the spatial order of the image, like the top left and stay here and the bottom right stay here. So we only use the final feature map. All right. So when the network pay attention, it's gonna select what region in the feature map gonna be the feature to be processed through the LSTM to predict the network.
Can I ask a question?
Yeah, yes, of course.
So I see this problem is like a machine translation problem from text to text, right? But instead we put the text in, we put the feature map, right?
Yes, that's quite right, because the sequence to sequence method. Yeah, as I see here, this method use the sequence to sequence method. That means this method is kind of this framework is kind of used for converting any kind of sequence to any kind of sequence.
Oh.
So Basically, this first is firstly used in NLP for machine translation when you translate a sequence of word in another language to a sequence of word in another language,
Okay.
a different language.
Take this picture as an example. Why don't the machine look at the man at the back of the picture, but they only look at the girl?
As I told you, this is data driven. Yeah, if in the round truth, the caption in the round truth is more likely to select the object in the front and close or big object or something like that. So the model kind of learn that way.
Okay.
So if you want to train the model to pay attention on the man, you need to create some ground truth that focus on the man more than the woman, and then the model gonna learn about that.
Okay. So I want to relabel the data so I can train the model better. Like this image, I can relabel to
yes
tell
to
the
pay
species
to
of
tell
the
the
man
model
and the woman in detail, in more detailed way.
Yeah, in a more detailed way, I assume that you may need to improve the problem into the paragraph generating instead of just one sentence. In one sentence cannot hold a lot of information, but there are also some bigger problem than image captioning, that image paragraphing. Like from the image, you're gonna generate a paragraph that describe a lot information that can be found in the image.
All right.
Yeah, but that's gonna be a little bit harder because to make a paragraph gonna go smooth and the information is really and connected. It's quite a challenging problem in that.
Okay, gotcha.
So what do you guys think about the image captioning? I mean the attention mechanism.
I think it's great because machine can look at different parts without put all the eggs in one basket. You know.
Yes.
Actually, the whole attention model came up because of limitation of memory to process everything at once, right?
Yeah, like you are given an image with a lot of people, crowded people. So what they're gonna say about that if you cannot pay attention and focus on small detail?
Yeah, and I think there was a recent. I was watching this YouTube video about the attention model applied to similar thing, but what they are actually trying to achieve now is, I'll just drop the link.
Yeah.
I think there's 2 points that is quite interesting here. I think you mentioned just now that for captioning there isn't like a good way to measure it, correct? So I think they are trying to come up with better ways to measure it. So this is like pretty recent. I think that's only 2 weeks ago. And they are trying to generate, like, I think the newest one is to be able to ask the computer like the right side of this women or the or object, what do you get, right?
About the question answering, right? So that is also the reason why I choose this paper, because kind of when attention mechanism went into the image processing, many methods later gonna use this attention mechanism for own kind of problem, like the question answering and even other problem that may require processing image, because they can how can I say, locally select the feature and reset part of it instead of the whole feature.
Yeah, and it also basically so this paper talks about 2 methods, the soft and the hard method. And I think in the recent papers, I'm not sure, like from experience, do you from what I read, basically like there is more. It looks like the soft method is better because because it being differentiable means like it's better, easier to train or it's easier to control.
Yes,
apply
but
methods on it. Yeah.
There also a trade-off that you cannot really control where and how much it's gonna pay attention to. A very likely example is mentioned in the paper as well. Let me see a little bit. There are a picture of two zebras that went wrong because of the soft attention. Let me find it. Here, a very good example of that. It recognized the two zebras standing this way to be a large white bird because the reason they pay attention to is two of them at a time.
Two of them at a time. What do you mean?
Yeah, I mean this is the reason they are paying attention to. So they look at two zebras at one time. So the actually thing they see is this kind of set, right? The two zebras, and this set make it look like a bird. That's why the model generated a large white bird standing in the forest. A large white bird.
Oh.
Oh, so it's kind of hard for a model.
But when you say the half attention, it is not big enough if you strictly define the reason to be that. So it can only look at this.
Right.
Yeah, but it's only look at one diagram. So it missed the other one. It just only look at one diagram. They had it here. Yeah, so sometimes when you use the soft attention, you hardly control where it's actually it's looking at. You need more data to make sure that this one is a diagram, and you should not look at the whole, but you should look at just one. But for like small object like this, the attention could get into trouble because with a big region, they can get the whole thing.
Yeah, and
if the object bigger, yeah.
Is it true that, I mean, if it's differentiable, then it's actually easier to converge?
Not really. I mean, the conversion is more likely to be the local minimum, and the approximate difference here is not really ensure to be the optimal model.
Okay.
So when you differentiable, that means gradient descent ensure that it's gonna go into the local minimum, right? Yeah, but the approximation is just make it close to the real gradient. So it's not really guaranteed to be the local minimum if you train the model with
so what you're saying is that if it's differentiable, because you can use deep gradient descent, then it's easier to converge than the hard attention.
Yeah.
Is that correct?
Yeah, maybe.
Because like I think that's like if we use reinforcement methods or approximate, I think it's just harder to converge.
Yeah, mostly the recent method refer to choose the soft attention. However, some methods also use hard because some argue that this is the way the human attention should be look like, and by looking at multiple reasons instead of merging a big one.
Is the difference between both of them that like the hard one looks at multiple regions? Because I thought the difference is actually, I thought as a human is closer to the soft because our eyeball don't necessarily just.
Yeah, it's hard to argue about that because we currently not really clear how human brain work. So it's kind of someone argue that way and someone argue the other way. In this paper, they also mentioned that a little bit. We talk about the heart attention.
Is there like a code that we can run from this? I just did a quick Google, but I can't really find.
I think there are. You can use the show attend and tell GitHub, and there are some, maybe some you can use it. Mostly they are TensorFlow implementation because this paper is practically quite old already. This is quite one of the basic and yeah. You can see the original code from the author is from Piano, not TensorFlow, and a lot of paper converted into TensorFlow.
Okay, cool.
So anyone have any other idea about the attention mechanism? Or any of your idea about the problem as well, the image captioning? People often ask me, what is the point of image captioning? Or you mean, what can we use? What is the application of image captioning when we can show it? What do you guys think?
I actually talked with my lecturer about image captioning, and we discussed about how this can be applied to the industry. You know, so he told me that there's some part that we can apply, like we can sell it to the TV commercials that they can use it for searching image like that, because they have a bunch of multimedia data.
I see. Yeah. Yeah, people just need to put the image, right? And the model can generate the description about the content, and we can search in via text rather than searching via the image, comparing image.
Yeah,
That's also a good way.
I was thinking, actually, is it possible, like, let's say you talk about like a movie, right, that is 1 hour long.
Yes.
And then you run image captioning on, let's say, every 10 seconds of the images. Then you get a bunch of text out. And then is it possible then to do some form of summary on?
Oh, yeah. That's also a problem people are working at. You can say the video captioning, the captioning for the video or video summarizing. Yeah, there are also problems about that. And actually applying image captioning along on the video to summarize it kind of quite hard.
Yeah.
Because some action, some action only can be fully understand
through motion,
right? Through motion.
Yeah.
Yeah.
And I was thinking this sounds like a multiple sequence to sequence layer. So after you pass through it, then you need like a way to do feature extraction on the whole storyline.
Yes.
Yeah, I mean that would be a really difficult thing.
So the reason I choose this paper is it's a quite basic and a breakthrough for image captioning and the more understanding about how we can process the image. As I also mentioned about the previous one, some previous method often use, how can I say, given human knowledge into the model. Like some early method try to detect object, like there is a bird in it and there's a human in it, and they're gonna give into the template sentence that there is a bird in this picture, or the picture is about a bird and a human or something like that. So what do you guys think about for that? method.
Can you say that again? Like
Yeah. Yeah, like in the deep learning method, we're gonna generate the sentence directly, right? Yeah, but in the previous method, like the traditional method, we haven't had the tool to generate a whole sentence yet. So people decided to try some template like the picture is about an object like, and what is that object is you have to fill it. Like you detect a bird in the picture, so you fill the word bird into the object. So this the sentence gonna be the picture is about a bird and a human.
Oh.
Yeah.
So
and yeah,
it doesn't basically use RSTM to train it into like a sentence. Is that what?
Yes. Like you detect object and then you fill what, and then you fill the object into the template sentence.
Oh.
Yeah. Like this is the picture about dot blank, so you have to fill into that.
Right.
So you
So
just detect one object at the end.
That's more of like object detection.
Yeah. One good point about that is it always ensure grammar. The grammar is always right, always correct, because you prepare the grammar for the sentence. For directly generating, sometimes there are some problem like it gonna miss in the grammar. Like you need it to be in past tense, it cannot go in that, or some word gonna have to go with the different to be, but it gonna give another word or something like that. So directly generate sometimes they're not ensure correct grammar or full sentence, or sometimes it's gonna get some problem like repeating word or something like that.
Yeah, I guess, but it doesn't feel very human though.
Yeah.
Hey, can we go through like in the last 10 minutes, like some of this, like results from the paper itself? And I know that this is part of your right. So I want to understand, because like the paper actually talks about the heart attention being slightly higher score for the blue 1, 2, 3, 4, right? Most of the time. And I find that surprising. Oh, it's actually very similarly scored with the soft attention.
I think because in soft attention, some of the example get fail, like the zebra I have shown you. That's the reason why the score gonna go a little bit lower, because of some mistake. For the half attention, maybe because the image is not really hard enough to challenge it, but it kind of just select a small reason, but ensure that it's gonna look at the right thing, not really choose the wrong thing like the soft attention. So it is sometimes slightly higher. One thing that the metric, this metric is mostly compare on the n-gram matching. So when you missing one word, that's gonna be a very big downgrade for your score.
Oh, that's true. Do you think it's possible to take a normal LSTM cell and actually bake the attention model in?
Actually, the attention model is quite easy to implement. It's just like a fully connected layer with the softmax on the from the activation function, that you make sure the generated weight to be equal 1 in sum. Yeah, if you look at the model, it's quite simple. It's just given the wave and something like that, you're gonna make the tank or the sigmoid something like that and activate through a softmax. So you have to wait, and then you multiply the weight with the feature again to select it and sum up to create a final feature. So it's kind of like one single layer along with the network.
Mm-hmm.
Yeah, just like multiply through for multiply and then activate it through a tank function and then put through a softmax to make sure the sum is equal to 1 and then multiply the score with the feature map. This everything of this is corresponding to one region, one area in the feature map. Multiply it and then choose based on the weight. For hard attention, the S is equal 1 or 0. For soft attention, the S is fuzzy, like 0.9 or 0.1. So the softmax function in the soft attention is ensure that they are within the range of 0 to 1 and the sum E equal 1. But for the hard attention, we kind of use a different, not the softmax, but kind of only choose the max one. So it's not soft, so it's called hard, and the softmax, so it is soft attention.
Mm. What is the use of the random choice? Sorry, can you hear me?
Oh, excuse me, random choice.
Yeah.
It's not really random choice. It kind of weighted some. So the one with the more actually I choose this one from this picture is kind of represent the whole attention model. So the random choice is kind of for the half attention in case of the score are equal.
Okay, I see.
So you only choose one in among the reason, right? So if the score are equal, you have to choose randomly from no equal score. For soft attention, we don't really need to do that. We need to sum up, just sum up.
Okay.
The output.
Okay, cool. All right. Does anyone else have any questions?
I have a question. So I really inspired by Mr. Ang by the topic image generations, image captioning, right?
Yes.
So after I talked to Ang a couple months ago, I started like a RNN course on Coursera, and I learned it for like 4 weeks. And I start trying to implement the image captioning. So and I read these articles on Medium, and a guy saying that LSTM is dying, right? I don't know, because I've been studying for 4 weeks and they tell me that LSTM is dying. I don't know, and they refer to in newer models called the transformer. So what do you think about the new models transformer, and can it use in image captioning to improve the accuracy of the model?
Yeah, technically, any model that based on the sequence to sequence framework, it can be used in image captioning. Like if it can receive a sequence and generate another sequence based on the data. So I think the transformer is also can be used in that way. And about the LSTM, yeah, it may not really, they are called the long short-term memory is because the short-term memory, not really the long-term memory. So technically, it's still, I think it still had the problem of how to consume, how to how to conserve the information for longer processing for long sequence.
But the problem of the LSTM is like trying to approximate the current time steps plus the previous time step, right?
Yes,
so
yes.
It's kind of computationally expensive when you backprop.
Yes, that's right.
Do you have any idea of how you can improve your model?
Oh yeah, currently improving model is you can use a better feature extractor. That's the one of the way. Yeah, some recent method are replacing VGD with ResNet, and one of the problem about generating is that you have to ensure the generated sentence to be correct in grammar and more human-like.
Okay.
So that comparing, because actually that's also a problem to how to say about improvement, because the current metric also are also not really accurate in comparing them, because like blue metric, they compare based on the n-gram comparing. So something like synonym or the passive form or some other kind of the way we can express what the same meaning in different way, then blur metric cannot do that. It has to make the sentence to be exactly the same to have a very high score.
Yeah. So I think the best metrics right now is human, right?
Yeah, the best metric is also human, but that's also arbitrary. It's also hard because in some way, in some person gonna prefer to caption this way, but other person may prefer to pay attention on other object to describe in the image.
Actually, to answer that question, I think you can look at the YouTube video. There are some like recent methods on how to quantify that.
Yeah.
I think human is one part, but they are trying to come up with images that are more objective.
Yeah.
So the Coco data set, they are talking about some of these biases, right? So they generated a new data set for that, for the test. But that will be a next discussion. All right. Does anyone else have any final questions? No.
Johan, any, or Leonardo, any idea about the topic or the problem? Anything related, like what do you think about image captioning or related problem to image captioning, or what do you think about the current method for that problem?
Well, this topic's pretty new to me, and I've actually spent the summer like studying the BERT algorithm with like the transformer for the summer. So it's like really interesting, especially when I'm sorry, like the previous question about the comparison between transformer and LSTM. I think like such things is really informatic for me.
Yeah. So you are currently working on machine translation?
I mean, I was so during my internship, I was working on like using the BERT algorithm to do some NLP task. Yeah, and I've also, but not anything about image captioning. Yeah, so it's more like NLP, how to like classify and yeah.
Actually, is one of my friend used to said to me that he intend to use BERT into image captioning via how can I say, to encode the sentence into the meaning space, right? BERT is used to encode the sentence into the meaning space, right?
Oh, okay.
Like the work to back, like, right? I remember that.
Sorry, didn't catch it. Can you say it again?
Yeah, I mean, you mentioned the BERT algorithm, right?
Yeah.
Yeah, so I remember that it's some kinds of work to vet.
Oh, I mean BERT.
PRT,
B
BRT,
BERT, like
PERT. Yeah,
Oh,
I
Bert.
BERT
yeah.
algorithm.
Oh, there
Yeah.
recently a model that beat Bert. It's called the XLNet from Facebook, I guess.
Yeah,
Yeah, this is one,
that's
right?
a better BERT.
This one, right?
Yeah.
Yeah, I remember that this is kind of work to vec. Like, how can you convert one hot vector into feature space of the world?
Yes.
Is that correct?
Yeah.
Yeah. So this also can be used in image captioning. Like can you convert the work into the meaning space and comparing them.
Can this also be applied to generating words from an image? Like,
Yeah, I think so. Actually, currently, as you know, we mostly use to generate a one hot, but
yeah.
generating the feature space also one kind of one of the options.
Okay, that's an interesting area.
Yeah, actually, if you think about that, the image captioning require a lot of processing related from both computer vision and natural language processing, because you have to process the image via computer vision, right? And you have to process the sentence as well. So this topic is kind of the merging area between the two.
Okay.
One question.
Yeah.
What do you think about LSTM and GRU?
Yes.
I think GRU. I've read some papers about they have the same accuracy, but GRU is a little bit faster because it has more less operations. What do you think about accuracy?
Yeah, I think I think that is correct about the faster processing, because the basic recurrent unique, right?
Mm-hmm.
Yeah. I have looked at the we can look at so it calculates less using less computation than the LSTM, but I think LSTM is kind of I'm personally I prefer LSTM because they have the gate to not only to control the input but also control the output. So sometimes you update the cell, but you don't really have to necessarily use the information you have been updated right away, but you can still use the output from the previous step without using the cell. So personally, I still prefer LSTM rather than KT.
Great. Well, I was thinking about one real application. For example, for blind people, we can put a camera and try to make captions of the word in order to caption the word, caption the environment in order to that the blind person can recognize what is touching, what is happening around him.
Yeah, that is a great application. But
Mm-hmm.
I think it's still quite far from that,
Yeah,
because
difficult.
real-time processing and other stuff as well. One thing about the image captioning is some people consider it as a basic the visual Turing test. Have you know about this? the Turing test.
Can you show us about that?
Yeah, the visual Turing test. Any of you have ever heard about the Turing test?
Yeah, it's quite famous.
Yes, yeah. So the original Turing test is basically based on language. Like if we talk to a machine and we cannot recognize it, then it's a kind of nearly intelligent, right? But the visual Turing test is require the computer to understand the visual information as well. And image caption is kind of one of that. If you given an image and you receive a description and you cannot tell whether it's a computer generating or a human generating, then the computer is considered to pass this test because it can mimic the way human describe a picture, which require a lot of processing.
I think the object recognitions are already passed this test because already passed the accuracy of 95%.
Yeah, not really because the Turing test making that can you separate that is it the reason from the computer or the reason from the human? So it may be require more than just saying what is in the image, but people consider often sometimes put their emotion into the description or some thinking like a beautiful girl or a lovely boy or something like that. So how can the computer understand the word lovely and beautiful through visual information to pass the test?
Yeah, right.
Is there any other questions from everyone? Oh, hey, Lynn, I think you sent the message to me privately. Maybe you need to pass it to Anne. Okay, so if no one have other questions, I would like to do a quick recap here. So in case we're not gonna stop the discussion here, we have our online communication channel on Slack and Facebook group to continue on the discussion. So I will post the video record of this meetup plus the slide and the source code from Anne on that on the link of the Slack and Facebook group. So feel free if you have any other questions, you can jump into the Slack and Facebook group to ask Anne. Okay, so we will have
one question.
Yeah, sure.
Oh, yeah.
Leo, yeah.
You were talking that every week you're going to have one person who explains one topic, one paper. Is it correct, right?
Excuse me?
I don't quite get your question.
No, his question is whether we are doing this on a weekly basis.
Oh, we do this so far we do this on a bi-weekly basis. So every 2 weeks, then we have one topic for discussions, and you guys can volunteer to share your thoughts on any papers that you like. So just tell me whether you want to register to host a paper.
Maybe next time could be Bert. Yeah, this is one.
Yeah. So for the meetup in the next 2 weeks, it's gonna be Patrick talking about distilling knowledge, right?
Yeah, knowledge distillation.
Oh.
Distillation.
Yeah. Cool. Okay. So I think let's keep in touch on Slack and Facebook group. The link below. The link is down below.
Oh, thanks for turning up, everyone. Have a good weekend.
Yeah, goodbye, guys.
Have a great
Thank
day.
you.
Touch
Have a
everyone.
good weekend.
Bye bye.
Yeah, goodbye, guys. Have a good weekend.
Thanks for the presentation.
Yeah, I hope you guys can use something today for your work in the future. Thank
Definitely.
you.